Hello, everyone, and welcome to a Weedy Special Spotlight, Building the Right Foundation for Artificial Intelligence and Prior Authorization. This is sponsored by Vitality Health. It's my pleasure to introduce the CEO and founder of Vitality Health, Mr. Michael Lunzer.
Thank you, Michael. Appreciate the opportunity to talk with you all today. Again, my name is Michael Lunzer. I'm the CEO and founder of Vitality Health. I have with me today Chad Frank, the Chief Product Officer and COO of Vitality Health. I'm going to turn the presentation over to Chad in just a minute. Essentially, our key topic for today is really talking about how to build the right foundation for AI within prior authorization. And the highlight of that topic is the importance of policy digitization and policy structuring. Policies form the foundation of prior authorization decisions and ultimately help drive the data and the information that needs to be gathered from providers. And so we're going to talk about some of the nuances and the important elements of policy digitization and turning policies into a computable format, which again forms the real foundation of AI in prior authorization. So for a format today, we're going to go through a presentation that includes a number of illustrations of critical points, and then Chad and I will discuss some of the important elements within those. So with that, I'm going to turn it over to Chad. Before I do that, I just wanted to mention, Michael, we have quite a few people in the waiting room.
Yep, admitting them now.
Okay, great. All right, so Chad, I'll let you drive the presentation and we'll discuss along with the guided elements.
Yeah, that sounds wonderful. Thank you, Michael. Before we get into too far, I just wanted to walk everyone through some major topics we'll be covering today. And we hope this topic logically flows from the rationale of what we're talking about, the use of AI, how to digitize policies, how they're important, and then considerations for payers or others trying to digitize policies. But before I want to get going, there's a few terms that we'll be using throughout the presentation that I want to put some definition to. One of those is clinical intent, and it comes up a lot because the medical policy itself is defining what the clinical intent of the researchers and the policy is. And it's important to note because that needs to be maintained at a super high fidelity. And that goes to our next term as it goes through the process, and that's policy fidelity. So as we look at, or you're looking at, how do you take your prior authorization? How do you understand what the policy is? It's really about a high policy fidelity. And by that, I mean, how do you preserve the clinical intent using the term policy fidelity? It's a state of being that goes through all your technical workflows and decision processes. And to do that, the other term I'm going to be using is structured policy. That is the asset or the actual thing that's in the computable system that allows you to manage workflows, make decisions against, and report on. And really what that allows you to do is what's called deterministic decisioning or deterministic execution. And that means instead of having a human with variability try to interpret a policy or AI try to interpret a policy, how do we make sense of the clinical intent of that policy and make a deterministic decision? So those are four key terms we'll be using throughout the presentation. If anyone has a question or wants to talk more about it, let me know. It's clinical intent, policy fidelity, structured policy, and deterministic execution. And so the agenda today is going to follow along very similar format of what we just talked about on those terms. And that is why medical policy fidelity matters. How do you define a high fidelity medical policy? And again, the policy fidelity is about how do I maintain that clinical fidelity, the clinical intent of the researchers and the policy, and then how do you operationalize it? So if you're on the technical staff or on the business staff working with your technical staff, how do I take this PDF, this HTML document, whatever it is, Word document, and how do I turn that into something a computer can use to support all these transactions and make deterministic decisions on? And then what is the benefits of using AI with that? So we'll talk about that, and we're going to step through all these processes. And the last thing we'll get on today is practical considerations for payers. And as Michael mentioned, it's going to be Michael and I riffing back and forth and having discussions on these topics. So the first thing we want to do is set the foundation of really what we're trying to talk about today. And that is looking at this concentric circle and really starting at the center of it. And that's That's what it is, what you're trying to do. You're trying to structure your policies. You need to understand your rules to how to apply those policies in different situations. And then how do you make deterministic decisions or execution and support interoperability? So, how you do that is you need to operationalize your systems, your APIs, your decision making around that deterministic decision and support AI responsibly, right? Put AI, we're going to talk about AI and how we want to use it and where it's the best place to be used. And then why are we doing all this and why are we talking about it? Well, to be fair to the patients, the providers, the payers, to everyone involved in the healthcare system, prior authorization requires consistent, explainable, auditable decisions at scale, right? That's why we're here today. And we'll be talking more about that, of really what's driving this momentum in the market and where we're sitting in the summer of 2026. And we all know we have that the pending deadline coming up of January 1st. So before I go on to the next slide, Michael, is there anything you wanted to add or talk about here before we move?
Yeah, I think the key consideration here is to think about medical policies in the context that every medical policy is being used, hundreds, if not thousands of times to make critical care decisions that are also financially impactful. So one policy might be affecting millions of dollars of care and thousands of patients' care. So it's really important that these policies be interpreted or put into a computable format that's extremely accurate when compared to the human readable version. And that's really what we're going to talk about today is the importance of converting those policies into a computable format that can be used to make deterministic decisions, again, decisions based upon rules versus probabilities, and then be able to use those same rules-based policies alongside AI for additional cases where AI is really needed to be able to extend beyond straight rules-based decisions.
Thanks, Michael. All right, one more slide before we start getting into the nuts and bolts of the presentation. And this is really to talk about from concept to execution, there's five key areas here we're talking about. And again, I know we're repeating this, but it's really important to understand the journey we're taking you through today and what this really all means. And I'm going to use the word again, clinical intent. What was the clinical intent of the policy, and how do you ensure that you're operating and making decisions based on that accurately and consistently? You need to move from clinical intent to what we're calling a high fidelity structured policy. And high fidelity means I'm not losing anything in what was there for the clinical intent of that. That means any of the rules or circumstances, regulations, measurements that were part of the original policy. I need to turn that into something that's structured and usable by a machine, but also supports human interaction. And that's how we're talking about moving from clinical intent to a system that understands a high fidelity structured policy. When you have that, that allows you to make deterministic decisions. Again, a deterministic decision is that every time I have this input, I get the same output versus somebody trying to read a policy and interpret it, or AI trying to read a policy and interpret it. And then you have drift and variability in your decision making and processes. And that's what we're trying to avoid. And there's ways to do it. You can avoid this and you can have this. And we'll talk about great, how do we get to a structured policy? We'll talk through that in the deck today. When you have that, then interoperability becomes much easier. You can exchange data across systems, across people, whether that system is internally for you as a payer or a delegated vendor or a TPA, or whether that's you're interacting with other payers or providers or patients, right? You have a single source to choose for that. And then once you have all that in place, AI really becomes into power because it allows you to drive even faster, I would say, exception decisions as part of the process. And really, the deck is going to follow this similar process: clinical intent, structured policy, making deterministic decisions, interop frameworks, and using AI to support that.
And we'll talk more about it a little later on in the presentation. But essentially, I think what we're trying to explain is that this conversion from a Word document into a computable format policy needs to be guided by rules and algorithms, not AI. So converting a policy into a computable format needs to preserve those core elements of a policy. And the best way to do that is to guide that policy through that transition with a human participating. Because again, these policies are being used many, many times. So the fidelity is really critical.
Thanks, Michael. Now we're going to take, and I know everyone's probably anxious to go going, great, that sounds good. I want 5 of those things. And another person saying, I want 10 of those things to make this work. I'm going to take a soft left turn and talk, before I get into that, and talk about why we're here today and why policy fidelity matters. What we're all seeing and what's driving our conversations today, and why we wanted to have this, is three converging forces are all hitting all of us in the market today, and we're all trying to make decisions on how to do that. And we're here to tell you how to do it. We know how to do this, and that is what's driving everything right now for the January 1st deadline is the CMS 0057F regulation. In addition, you have a number of payers and patients, or sorry, providers and patients all wanting faster decisions, closer to the point of care. And then AI is becoming inundated in our everyday lives. It's on our phones, it's in our computers, it's in our business systems. We see it everywhere being published about how AI is changing the world. And there's always stuff on cost and data centers, but really it's about how in the medical world, how AI is being used. And these three things are coming together to why this is going to matter now. And this is why the presentation's about. So AI adoption is accelerating at rapid paces across the industry. We did a poll in one of our last presentations on this, and there was a staggering number of people that are already using AI in various forms in the healthcare world, at the payers, and starting to looking at prior AI within prior auth. So we're seeing a lot of that from the payers we're talking to. They're starting to use AI or want to use AI for coverage decisions. It's being positioned as a key cost reduction. But on the flip side, we're also seeing, if you're watching the news, increased regulatory scrutiny. We're seeing laws come out in various states or counties or jurisdictions about the use of artificial intelligence to make decisions and how it's being used in prior auth or other parts of healthcare. And when you're using it, we are in a regulatory or regulated environment. We want to understand the decisions being made so we can be open and honest and understand what's actually happening. And a lot of times, if you're using AI, some of that nuance of how it's making decisions is a little unclear. So, what we're really seeing, and the point of all this, is AI adoption is accelerating faster than policy modernization. And by policy modernization, it's the things we've talked about in the past 2 slides of how do I take clinical intent of a policy that's written in PDF, put that into a computable form, and that's what we'll talk about how to solve that today. Here's what we're seeing when we're talking to organizations across the industry, specifically for payers. They're coming at this regulation of CMS 0057 and saying, okay, I have systems today. I need to connect my systems with the providers, with my other payers, with patient access. And I have systems where my policies may be stored in Drive somewhere. I may have my applicability rules in spreadsheets or in other systems. I have a bunch of workflows I'm trying to automate. And what we've seen a lot of payers focus on first is how do I connect all this together? How do I connect my payer to my hundreds, if not thousands of providers? How do I connect to other payers and how do I meet these regulations? And we've seen a lot of people coming at it from a technical digitization workflow perspective. What does it take to take what I have today and make it work? We're also seeing people look at it and say, okay, well, I have all these steps that are manual or automated. I need to consolidate them and I need to manage them. And so I'm taking what exists today and just making it digitized or making it work within the workflows for the specification. And a lot of times they're saying, well, I'm trying to understand my policy. I'm trying to understand clinical intent. I'm trying to understand my rules. They're in disparate systems. They're unstructured. How do I make sense of it? We'll just throw AI at it, right? But the key point is the quality of your policy digitization is going to determine what comes next. You need that solid foundation to make it happen. And the one thing we want to remember is that your clinical teams on the business perspective, despite what's going on with regulations for CMS 0057, there's 3 key things they need to do for every prior auth, and they need to be right. And they need to be accurate, and they need to preserve the clinical intent of that policy. So first of all, anytime there's a prior auth that comes in, somebody has to decide, okay, which policy does this apply to? Right? Which one is it? You can have procedure codes or procedures across multiple policies. Then you have to get into benefits and is this even covered for this person? And then the person has to make a decision based on the clinical criteria or the medical necessity of that policy. So all these things depend on how accurate that policy is being represented in your frameworks, in your infrastructure. Anything
I
you
w
wanted to add to this, Michael, before we start jumping into what is a high fidelity medical policy?
yeah, I would also take a step back and really just focus on these three categories. There are different approaches being discussed. We've seen some organizations that point AI at a policy Word document that might have 50 pages that kind of cover the whether or not that policy applies, somewhat talk about coverage and include clinical criteria, but it's buried in the 50 pages of the medical policy. The danger of that is that when given a choice, AI will find the information that it wants to find, or will find some information that it finds relevant. And it may not find the information that is relevant. It does a great job, but it might be 95% accurate. So if it's not finding the information that clearly defines the coverage and the whether the prior auth is required and what are the clinical criteria elements, without structure, there's a possibility that the decision doesn't align with the policy and with the rules of the health plan. And so that's essentially why it's critical that these core elements of policy alignment to procedure codes, coverage, and which clinical criteria are very closely aligned and again have extremely high fidelity.
Yeah, thanks, Michael. And I was reminded talking to Anna from our marketing team earlier this morning that it's one point to add on here to expand on what you said is even if it's finding things, even if it's a human finding it or AI finding it, right? It's open for interpretation, and that's really the last thing we want. And whether it's a human trying to digest and absorb hundreds and hundreds of pages of information, or an AI or bots trying to do it without deterministic rules, even if it's there, it's open for interpretation. And we're trying to eliminate that open for interpretation, both from a human side and a machine side. So, what determines AI reliability? Well, our stance is we believe it's your policy fidelity, how well you're preserving the clinical intent of that policy as you're digitizing it. And if you're putting AI on top of it, your AI can only execute what the policy is representing. So let's what we're going to roll into next then is defining, all right, what does a high fidelity medical policy mean? And then after that, the next section after that, we'll get into how do you create this in a system that moves it into a deterministic decision based on a structured policy. So a high fidelity medical policy is really it's out there to turn what we're talking about is even when it comes to digitization, we're not talking about taking a Word document and turning it into PDF or PDF into HTML. What we're doing is saying, how do I take all these words, understand what they mean, put it into a system that can compute it and understand it, and also be used by a computation system or a computer or a network or system, but also by humans, right? So you have to solve both of those cases, and it needs to be the same policy whether a computer's using it or a system's using it, as well as the person. And so, really, what you need there's three key elements here. You need to put a digitized structure to that policy, while preserving, and this is where high fidelity comes in, the clinical intent of that policy. You need to understand how that policy is applied. You may have a policy for knee replacement that may be different from your commercial line of business to your Medicare line of business, and it also may be different even in commercial between your different clients you're using or your different groups and exceptions. So you need to understand the applicability of when to apply it. Then you need to be able to support how decisions are made based on the medical information coming in, the intent of that policy, and the rules of when to apply it. And so those are three very core things that we'll be talking about that we are trying to preserve that will enable this to be successful. Anything on this wanted to talk about, Michael?
Nope, that's great.
Okay,
Thank you.
wonderful. All right. So when you have a structured policy or a high fidelity policy within a system, there are three big things you get out of it. You get consistency. And again, this goes back to every time I get the same input, I get the same output. We are trying to remove interpretation either by a human or by AI. You want traceability into this decision was made on this date. what happened in the transaction, why was the decision made, what artifacts were incorporated, and what rules applied. And you need to lock those in for your compliance teams. And then you want to be able to repeat that. And if you're a plan that's getting a 500,000 or 1 million prior auths a year, you need to repeat that at scale. And you don't want to deviate. You want that consistency there. And what you need to do that is what we're calling is a deterministic policy and rules. And when you have that, you can easily support your integration in your interoperability frameworks. The big ones everyone's working on right now are CMS 0057, and it's for CRD, DTR, and PASS. So when you have this framework of a single policy that can respond to anything, whether it's a human or integrations or systems, and it can be deterministic, you can support all that. You can do this at speed or at scale. And the most important thing is we're all going to be using AI, and we use it in our tool sets too, but it allows you to have some guardrails and structure to use your AI that you can count on.
I think there's one point here, and it's the chicken and an egg question. Um, in this particular case, I think ultimately CMS 0057 is driving us to a digitized policy, which ultimately obtains or gets us to that integrated world. The well-structured digitized policy then also supports the decision-making at the payer and even at the provider of what data to put into the questionnaire, how to answer those questions. And at the payer, it allows for the use of AI to compare medical records with the questionnaires that are produced for DTR.
Thanks, Michael. And the last slide, and what I'd like to do, if it's okay, is we have one more slide for this section, and then we're going to talk about how do you operationalize a structured medical policy. And I'm going to pause there for a minute. And Michael from Weedy or anyone from the Utility Health team, if there's any questions that you're seeing that Michael or I can answer to keep, that would help us continue the flow and make sure we're all on the same page here. I'll take a break after the next slide, and we can answer any questions that may have come up before we continue on the first half of this presentation. And Michael, this next slide is one of your favorites. Maybe I can just let you start with it if you like.
Sure, sure. The essence of this concept is that, again, we're using one policy for many, many transactions. A typical payer might have 400 or 700 policies with all of the various rules and decisioning, and those policies might be used for 400,000 prior auths or 800,000 prior auths. Those prior auths, the vast majority of those transactions should be able to be determined directly by the rules inside of the policy with structured data. In other words, a policy criteria gets turned into a computable questionnaire. Within that questionnaire, the technology exists to know that if a user says, yes, the member meets this requirement, and no, they do not meet this other exception, we're going to go ahead and automatically approve that prior auth submission. So by having those rules built in to the medical policy DTR questionnaires, that allows for the vast majority of prior auths to be decided on factual deterministic basis. They meet this requirement, therefore we allow approval. For those scenarios where it's not quite that clear whether or not the patient meets those requirements, that's the 50,000 transactions that fall out of the process by not being able to be deterministically decided. That's where we now need to use AI to dig through the medical record and compare that medical record to the medical policy questionnaire and allow a human to have extra oversight to determine if this is a prior auth we can approve or if it needs to be rejected.
Thank you. And I want to take just a quick second to talk about the concept of the slide and why we developed it. And it's really meant to have people take pause and think about what's actually happening. And on the left side of the screen, you have an interpretive review. And that interpretive review could be an individual, where a prior auth comes in, somebody has to make a decision on what policy this is. They have to determine whether prior auth is required or not. On a full submission, they may have to look at clinical medical records, either pen to approve or deny. And then that rinse and repeats 450,000, 700,000 times. Or we're seeing in some cases AI is doing the same thing. A procedure comes in, AI interprets the most recent medical policy. AI looks at it, tries to interpret the medical records. It doesn't, in a lot of good cases, AI isn't making the final decision, but it's providing guidance, and it rinse and repeats. And there's a lot of interpretation happening. Whereas the right side is what we're talking about is when you can understand and digitize your medical policies into a structured format, maintaining the clinical intent, you understand your rules around that. When does this policy apply? What line of business? What group? What exception? What client? And you put that into the structured form, as Michael was talking, you can automate that. And there is an interpretation. You're getting consistent, repeatable results at scale. And that was really the intent of this. And I just wanted to drive that home in case people were wondering the difference between the left and right hand sides of the screen. So this is where we're going to get into. This is all well and good, Chad and Michael, but just tell me tell me what you're seeing and how to make this work and what does it look like. And this is where the next half of the presentation gets into. But before I do that, for the Utility Health team or Michael McNutt, was there any questions that you feel would be valuable for Michael and I to answer at this point?
Oh, not at this time, no. Just
Okay.
a regular question, folks. The slides and recordings will be sent to all registrants post-event.
All right, thank you. All right, let's move on. Okay, so the next sections now we're going to get into how do you operationalize a structured medical policy? And by that, I mean, how do I take this PDF, Word document, HTML, wherever this is, and how do I put it into a system that I can act upon it, and in this case, to solve CMS 0057? How do you do that? Well, here's how we see it, and here's the foundation that we're using. You first need to start and look at what are your policies, what was the medical intent of it? How do I maintain that? What are the rules around when and how I use this policy? And you need to put it into, we're calling it a platform. In this case, we look at this as the utility health system, but I take this policy and I digitize it. I maintain the clinical intent. I also understand and maintain in a single system the procedure codes associated with it, effective dating, what is the content of the policy, is there rules around, as I mentioned, what line of business, what groups or carve outs? Are there forms that need to be submitted when somebody submits a prior auth? And one of the most important things that everyone is dealing with today is the questionnaires, and those are the FHIR questionnaires. How do you take that, what was written in text format, and develop a FHIR questionnaire that is readable by systems, whether it's the provider or internal systems you're making decisions, and utilize that? Well, that's what we do. And so when you have this structured high fidelity medical policy in a single instance of truth, you can easily support multiple APIs, different portals or integrations you might have, like provider portals, until the whole industry catches up to the direct integration between a payer and provider through CMS 0057. We all know there's going to be provider portals for a while here. You can support that. Maybe internal websites for your teams that need to go look at information of where's this policy, when was it last updated, what procedure code is effective on this date, what are our future drafts coming up with policies, and it's all in a single system that your clinical teams maintain from a business perspective. Again, that's different than how I'm trying to integrate my workflows from a technical perspective, and then ultimately supporting decisions. And this goes back to Michael's comment earlier on a single policy supporting everything with all the rules wrapped around it. Anything you wanted
And
to add here, Michael?
yeah, we try and make these presentations educational and less promotional, but I'm going to pause here and describe in context of this slide what the utility health policy platform does, and it's really illustrated in this picture. So the utility health policy management platform automates and manages the policy creation, editing, and publishing from the initial ideation of a policy all the way through the transparency where that policy is shown to the various systems or made available to the various systems on the right side of this. So the utility health policy platform replaces a single Word document with an entity a version of a policy that has each of the items in the center of this diagram. So that version of a policy knows what the criteria or rules are. It knows what documents are required from the provider to submit a prior auth. It has a questionnaire associated with it. It knows what lines of business or therefore members would use this policy. It knows which prior authorization codes are associated to this policy. So this policy management platform allows the users of the platform to define policies, associate or enter all of these various elements for each policy. And, and it also facilitates the creation of the questionnaire from a human readable form into a computable questionnaire in a way that, again, preserves the fidelity of that policy. Each policy is recorded with an effective date. If it has an end date, in other words, there's a new policy that replaces it, that end date applies. The editing and changing of policies is all performed through the platform using a workflow style of experience. So there was a question, for instance, that identified and said, can a policy's procedure codes change? The answer to that is yes. The user can come in and say, I'm going to add a new procedure code to this policy. The date that procedure code is going to be effective is some date in the future. That procedure code is going to apply to all lines of business or certain lines of business that apply to this policy. And when they save that rule, there can be an approval. Once that rule is active or published, then it's effective on its effective date. So we've replaced a process that is managed typically on a document-centric perspective and replaced it with a data-centric process that can create in real time the documents that people might want to see in human readable form or the questionnaires that computable systems need to be able to retrieve.
Thanks, Michael. One of the things I want to hit on in the next slide is I want to dive a little bit deeper into that questionnaire generation because I know that's a question we get asked a lot in the field or at conferences when people are talking to us of that's really kind of where the rubber meets the road from a lot of the technical staff on how do I take this and build a questionnaire that's consistent and repeatable and not open for interpretation. I'm going to use the next slide to talk a little bit about that. So this is very similar to the slide we just talked to with a slightly different perspective, and it talks about five key things here. And one of them is, with a single system where you're managing this, you have a single system, as Michael mentioned, where you're editing versions of policies, you're editing versions of rules, you're making changes, and it's all there, and it's not left open for interpretation or subject for questioning, right? And then what you have is when you ingest your policies and rules, you have this single system where the policy is stored with the explicit logic, relationships, metadata, questionnaires. And here's the cool part. Instead of using AI to try to take a policy and make a questionnaire, you now have two distinct things you have to maintain as a company, and you have more work for your clinical teams for item 3 above. So I'm talking about item 3. When you're maintaining the clinical criteria of your policies, or the teams, your clinical teams or doctors are updating the policy and changing criteria, that inherently uses system logic, defined logic and rules that are algorithmic that allows you to edit and change that and look at it with and or one of these, one or more, all of these, and this or that. In those rules, when you're looking at it, you're typing it into a screen and editing it, and whatever you type there embeds it within the policy, but it also generates the fire questionnaire. So you have no disconnect between an AI or somebody going, I have a policy over here, I generate a questionnaire. That questionnaire output may be different now. A few words may have changed, and it might be subtle changes, but those subtle changes can be big. And now, if you're trying to do that with AI, you have to go back and you have to look at the AI output, go back and look at the policy, edit those in both places and making sure they're in sync. The system Michael was talking about does it all inherently. So you don't have to worry about that disconnect between the criteria or medical necessity and the fire output that's being used for the CMS transactions. And so that's where really the power comes into step 4. I have a single place I'm maintaining it, It maintains it in the human readable place. It generates it for the fire questionnaire, and it supports all your endpoint transactions. And then you rinse and repeat that for every change. That change can be small. Maybe your procedure code, one of the procedure codes is been new and is published, and that just gets added on August 27 or August of 2026. That's the new effective date for it, right? Well, that changes how your questionnaire is, how the policy's read, how you make decisions, but all those even little changes down to the text in the policy or medical criteria are all in that single unified place being maintained with those relationships. And then that person, the clinical team, just publishes it and everything is synchronized throughout the entire system. Before we get into what a highly fidelity structured policy looks like and the risk you'll find by not having that, was there anything here, Michael, you wanted to add to that, or from kind of tacking on to the next slide and talking about risks and not
Yeah.
doing this?
Yeah, I think there's a good question that's been asked, which is, how is AI layered into this process, and where does it apply? And so I think the critical element is that the process of creating a structured medical policy and a fire questionnaire is not the place to apply AI, because AI may change the meaning of a policy between a pure PDF document and a fire questionnaire. There's a lot of transformations that happen in that process. The utility health approach is to not use AI in that phase of the process, but to instead allow the human who's created the policy to see how technology in specifics, interpretive algorithms, not AI, how that policy is being converted into a structured format, a digital format, and then how that policy is being turned into a fire questionnaire. That process is so important that what we have created is a mechanism that allows the policy writer to validate each of those steps along the way efficiently. So we've been able to convert 700 policies into a digital form into fire questionnaires in a matter of months, without using AI and generating an extremely high fidelity output. And that's what's critical again to allow then AI to be a part of this process. So I think the essence of the question then is, where does AI apply? Well, now that we've got a very well formatted questionnaire and set of rules for a policy, if I send that set of rules over to a provider's system, if that provider's system has AI tools that allow it to dig through all of the various medical record information for the patient and answer those questions, that's a phenomenally perfect application for AI to go in and find the data, answer the questions, and now allow a human at the provider organization to verify that the answers to those questions are consistent with what the provider understands and submit the prior authorization. Another place where AI comes in really helpfully is after that prior auth has been submitted to the questionnaire, the payer can automate the approval based upon the answers to the questionnaire. However, after that prior auth has been submitted and received, the payer can make decisions based upon the answers within the questionnaire. And if the answer is it's approved based upon the answers in the questionnaire, the documents can still be there that help the payer to validate or audit those responses on an occasional basis with AI.
And
The other place that AI comes into place is for those prior auths that are pended and a decision hasn't been made, then we can use AI to help make decisions.
and to answer that question too, our next section covers how AI does this. So we'll get into some more of those detailed use cases as we kind of get into that. And our use cases will be covered on some benefits to the payer. But what really what I want to talk about is what we've been building up to, and that question's a wonderful question. It was the intent of this deck that AI has a place, but AI's place isn't necessarily well used when you're trying to create a structured deterministic system that you need to remove variability from, and you need to do it at scale. And that's what we've been talking about is AI is using data no matter what. So if the data AI is using needs to be foundational, and it needs to be accurate, and it needs to be structured to make sure that you're getting the best use out of AI versus interpretation. And so when we talk about this is really where a lot of the we're getting to some very key points is AI depends on your medical policy fidelity, right? And we want to talk through some of these before we get into the AI slides coming up. But the biggest one we've been talking about is the on this deck. And Michael, I'm just going to pick a couple, and I'll let you talk through a couple. And I know you're big on the fire questionnaire, so I'll leave that one from you. But a high fidelity or structured policy gives you explicit applicability rules. Again, we are trying to remove variability in inference in any of this, whether it's a human or a machine doing this. So when you create this foundation, really what you need to do is make sure that your applicability rules, and that is what line of business this is a policy applied to, what was the effective date, did the effective date of procedure codes come and go, were there small updates that were made, did those updates actually impact the medical necessity, or were they just informational or citations that were changed? How do you interpret that and understand when and where to use those changes? AI or who's ever making the system, whether it's deterministic or a person, you need effective dating, you need version history, you need to understand how those changes are happening, what was the effective date when those changes, who made them, how they apply. And Michael, I'll let you grab a couple of these. I know we're handing the presentation out, but I want to make sure we get through some more slides and anything you want to talk about other than fire questionnaires, which I'll let you start with.
Yeah, the fire questionnaire. In fact, there's a question in the chat as well. Um, the question was, is there a tool that helps a low-tech person to create that fire questionnaire?
Yeah.
And that is the foundation of the Utility Health Policy Management application. It has a function that allows a policy writer to use typical policy writer language, like any of the following, one of the following, the types of phrases that policy writers use, and see how those phrases affect the questionnaire, so that a policy writer, after 15 minutes orientation to the utility health application, can be creating very effective fire questionnaires that are then saved as a file that an EHR can see and reason and gather data for. That's really probably the most powerful element of the policy management application.
Anything else? Or do you want to move on, Michael?
Yep, I think we're good.
Okay. So how do we move? I love these questions. So how do we move from this? Well, here's how we do it. You start with a policy that's managed and authored by your clinical teams. And again, that policy also includes the clinical criteria that's being used to generate the fire questionnaire. And it's in a human readable, easily understandable way that a human or clinicians and clinical teams write the policy and write the clinical criteria. And where the magic happens is in the rules that we've used and how policies are written across multiple payers and across the industry of very specific things and language being used. And again, that's one of the following, all of the following, this and that, this or that, within writing the policy. And those Boolean logic rules are deterministic, and they are used to drive the fire questionnaires. So once you have the policy in a computable format, you can apply all your rules to it. And again, these rules of this policy applies to this line of business. This policy applies to these three client groups, but not this one. These procedure codes are attached to this policy at this line of business, but not the same policy at a different line of business or group. All maintained in a single place by your clinical teams. That's what gives you that deterministic executable logic. From there, everything becomes easier. The fire outputs are generated, whether it's CRD, DTR, and pass, and then you put AI on top of this. So here's what this type of data looks like. The center of this picture represents the combination of your policies being managed by the clinical teams, the association of rules and groups of the applicability of those policies managed by the same teams, and that can cover your programs, procedure codes, groups, custom clients. You then have all that structured data that supports your API and integrations, any client tools or admins you have, any web interfaces you're building, and the most important thing we're talking about today is artificial intelligence and where that's used. So that's where we're getting into the next section is how AI is used on top of this underlying layer.
Two very quick
Yeah,
notes.
yeah,
Sorry. Um,
it's okay.
when we talk about this process starting with a policy, um, we often talk about it because when we implement a new customer, we have 700 policies that need to be ingested into this product. But once those are ingested, the product becomes the foundation for creating new policies. So they're actually created in the system, and it drives standardization and efficiency at a very high level. The next component of this that we often get asked is, how difficult is it to maintain all of this data? Because this sounds like a lot of data. The reality is the system was built specifically to minimize the amount of work required. Our customers find this to be a very easy process and actually significantly better and more efficient than the traditional way of managing documents. Chad, you got a reminder showing up. Sorry.
What do you mean?
Oh,
Oh, thank you. Thanks, Michael. Sorry about that, folks. All right, so let's move on to how AI benefits from structured medical policy. So I'm assuming at this point we're all buying off that yes, we need we need to maintain clinical intent. Yes, we understand structured policy and rules. Yes, we understand it's in the system. Now back to the question we had a couple slides. How do you use AI? Great question. You put AI on top of all this data. And as Michael mentioned, one of the in a previous slide we had where we talked about those 450,000 prior auths coming in, and we said you can automate 400 of those, but 50,000 of those are exceptions. This is where AI comes in. AI is great at clinical summarization. AI is great at data extraction. So if you're a reviewer and you're trying to approve one of these exceptions for a prior auth submission, and you're saying, great, now the system now says, here's your medical necessity, your clinical criteria. I need to apply that to the 400 pages or 1,000 pages of information that just came in. This is where AI shines. Let AI go through all those clinical records, find the matches it has to the clinical criteria. We've established that the clinical criteria is deterministic and it's the foundation, and AI can be used to grab that foundational data and say, find me where in all these clinical records that this person is meeting the medical necessity. Have they met the medical necessity to approve it or not? So AI is great at that. And that's how we use it within our systems. We use it to take this foundation data, use AI to sort through lots of information, extract it, look at it, summarize it. And then there's other things it can do. It's great at communication support. It can help your reviewers. It can help you with workflow guidance. There's a lot of areas for it, but it starts with this foundational information. And I know we're getting close on time, Michael, and we got a few more slides to cover. Anything you want to cover here before we move on?
nope.
Okay. And this next slide just breaks it down. When we have a tool called Clinical Assistant, and when a reviewer is going in and they're saying, "Yep, I need to approve this exception," on the screen, they can say, here's the clinical criteria. 1,000 pages of clinical information comes in. It says, extract the data out of this clinical information and find a match for this first line item for this medical necessity for procedure code 12345. Summarize what I'm looking at. Help me as a reviewer get assistance on how I'm trying to make a decision. It's not making the decision, it's speeding up the time to sort through lots of information. And the cool part is because we have that foundation, you're not open to interpretation on medical necessity, and you're not open to interpretation on the clinical records. It's finding the potential matches and going through that information to assist you. So we have four more slides to go through. We'll leave it open for questions, but some practical considerations for payers. When we look at, again, a high fidelity medical policy is what we've been talking about today. When you put it into a system like Utility Health, put structure to it, maintain clinical intent, you get consistent execution, you have predictable DTR in your fire questionnaires, you have more stable interoperability versus building a couple of custom integrations. And the big one is it allows you to put governance or guardrails around AI because of that foundation versus leaving it open for interpretation. So this is what happens for outcomes. What happens if you're on the technical side of the staff? How does it change your system behavior from a systems thinking perspective? What we're finding, and there was a report published by Peterson Health that they found that with the use of AI, it actually increased a lot of system activity. There was a lot of bot traffic back and forth between the provider and payer, and it just created more noise to sort through. You end up with more back and forth transactions as people are trying to interpret or get clarification on different items. So from a system behavior, there's a big difference in what you'll see between using a structured high fidelity medical policy versus a low fidelity medical policy, which I'm saying is leaves it open to interpretation, whether by human or AI or machines.
Yeah, and ultimately, the CMS 0057 requirements are there to create a firm data structure, not a probability that a patient meets a requirement, but a definitive answer, yes or no, the patient meets a requirement. And AI is really great for those probable decisions. Structured decisions can be made as a yes or no if the data is there. And that's really what CMS is requiring with 0057 is a very firm structured data process that should generate 85% authorization decisions in real time without the need of AI. AI comes into play on the edge cases or those cases that can't be made in an automated fashion using the structured data.
All right, we got two slides left. One will be our summary for you as payers. Three key things we want to really drive home that the number one thing, despite looking at this from a workflow, automation, and systems perspective, is everything must maintain and preserve your clinical intent that's defined in the policy. You need to build a computable medical policy, which we've been talking about today. And then once you have that, you can apply AI on top of it. And that gives you a deterministic policy that enables scalable AI. And when you look at how the different products, the last one is just a little plug for Itility. We have five main products. How does that impact the workflow of prior auths coming in? And Michael, this is all you. I'm going to let you take over and give the pitch for this.
Yeah, I think that the experience that Itility Health has found is that by creating a really strong source of information that defines whether or not a prior authorization is needed, you can ultimately avoid typically at least 30% of all prior auths that are submitted today. And that's because providers, if they don't have a definitive source of whether or not PA is required, they will submit prior auths or they will just pick up the phone and call your call center, which leaves room for another significant room for error in that many health plans don't have a strong source of truth for is auth required. That's where Itility's PA checkpoint product comes in. The next section down in this illustration is the blue section, and it all starts with a policy. That policy being a high fidelity policy with a strong questionnaire that guides the provider to answer those critical questions and submit the necessary documents for an authorization. PA routing ensures that those prior auths are submitted to the right destination, whether that's an internal decision maker or an external delegated vendor. Auto authorization is where all of those submissions are received and then compared to the rules built within that policy. So again, the questionnaire of a policy can inherently have all of the rules necessary that when a provider answers the questions, the decision can be made in real time, like we would expect in today's modern web-based systems. That last percentage, 15%,
Michael,
is where the clinical assistant tool comes into play and applies AI. Yes, Chad.
I just wanted to add one thing on the blue section, and it's something we didn't talk, and I apologize for interrupting, but it's an important piece we didn't talk about. Almost all of the payers we work with have a large system of self-managed policies. They work with delegated vendors and third-party administrators. All the rules, and that includes companies like MCG and Interqual and Lucid and everyone else for behavioral health. The utility health system, we're not just talking about using it for policies you're managing. It can understand the policies from other systems and the rules around it as well too. And that's an important aspect is it's just not for your policy, it's the decision engine for your entire prior auth infrastructure.
So a couple of questions that I see that really drive towards uh, fundamental elements that we're talking about today. There's some questions around appeals and change order denials and things like those. And what's really critical is that the foundational data of medical policies and procedure code relationships all be well documented such that when a provider is submitting a prior authorization, all of the data is there in front for the provider. For instance, then when they're filling out a prior auth questionnaire, they can see all of the procedure codes that may apply to a section of that policy, and they can request prior auth for all of those procedure codes, not just the one that they're asking for. And then that allows the capturing of this data, the well-structured information to the provider allows for a more effective workflow system in the back of this process, meaning that when a prior auth is submitted, we're gathering data in a very structured, effective format. And now if there's a question after the fact, a denial, or somebody needs to look at the other data in this submission, it's all there for the payer team to review versus having to go back and forth and ask questions. Another question was regarding, the time it takes to get prior authorizations approved. Is there a way we can nudge the payer if there's an outstanding prior authorization? What we're addressing here are the foundational elements that help to streamline and automate this process. Ultimately, by creating a better process, we would expect payers to have a lot more time to process prior authorizations and to meet the new requirements of much shorter response times. The other systems that might nudge a payer to review things, those typically would be within the utilization management platform. So what we're really addressing here with our technologies are how do we get all the data in a structure that can streamline things in real time, and then give the tools to the payer, clinical resources, and to the provider to make sure that we're having a very clear, complete communication in the first time rather than having to request information later or do other things. Lastly, by getting this critical component of prior auth in a structured process that can automate the vast majority of prior auths, that leaves us time to perfect the rest of the process. This prior auth capability from 0057 is really just the beginning. It creates the foundation, and that really gives AI the data and the process that it needs to be able to really shine for those exception processes and that 15% that do need the assistance of AI. Yeah, there's a question about whether the health plans are finding that digitizing medical policies in this manner versus using AI is more appropriate. What we have found is that oftentimes payers start looking at an AI approach, but the policy teams are the first ones to raise the alarm that's identifying that if we use AI to create a questionnaire, there's a really significant process for validating those outcome questionnaires. And so using a tool to create those questionnaires is actually much more efficient than using AI to interpret those questionnaire, the policies for the questionnaire.
Looks like there's another question just popped up. How would this product fit into documentation systems?
That's a great question. So in the 0057 approach, the policy questionnaire is sent over to the provider for them to answer the questions and submit documents. When that package arrives at the payer, it enters a PAS system. That PAS system can be the tool that automates the decision on this prior authorization, and also then ingests the data the fire questionnaire and answers, along with the attached documents, into the UM system. So now the UM system gets to see the recommended decision from the PAS system. And if for instance, that recommendation is that it should be approved, the UM system marks it as approved, gives the authorization number back to the PAS system, and the PAS system, through FHIR, through this new CMS 0057 architecture, sends an answer back to the provider that this is approved. In the event that the prior auth is not to be approved yet and needs to be pended, the UM system gets all of that documentation, presents that case to a clinical reviewer. They can then use AI to assist in making that decision and follow the normal workflow of that UM system.
Excellent. We are at the end of our time here. Chad Frank, Michael Lunger with Itility Health. Thank you guys so much for a fantastic presentation. I believe the next time we see you will be at our summer forum, August 10th and 11th in Chicago, where we will have a 2-day deep dive into 0057 and 0062. So folks, be sure to check out all our upcoming events on our WEDI event calendar, including the summer forum. Thank you very much and have a fantastic day.
Thank you, everybody.